Hi everyone, in previous tutorial we learned about VLANs. We created two VLANs on a switch and assigned devices to different VLANs. As you can see, we have two separate VLANs in our network. The first group of computers belongs to VLAN 2 and the second group of computers belongs to VLAN 3. Each VLAN is a separate logical network. Devices inside the same VLAN can communicate with each other. For example, computer in VLAN 2 can communicate with other computers in VLAN 2, and computers in VLAN 3 can communicate with other computers in VLAN 3. However, devices in different VLANs cannot communicate directly with each other. For example, if a computer in VLAN 2 tries to communicate with a computer in VLAN 3, the communication will fail. This happens because VLANs are separate broadcast domains, and a layer 3 device is required to route traffic between them. The router will allow devices in VLAN 2 and VLAN 3 to communicate with each other. We will connect the switch to the router using a trunk link, add router subinterfaces for each VLAN. Now that we have added the router, we need a way for the router to handle traffic from both VLANs. A normal physical interface on a router can belong to only one network. However, in our case, we need the same physical connection to communicate with multiple VLANs. To solve this problem, we create logical interfaces called subinterfaces. A subinterface is a virtual interface created on a physical router interface. For this instance, we need two subinterfaces. The first subinterface will be assigned to VLAN 2, and the second subinterface will be assigned to VLAN 3. Now that the router has a separate logical interface for each VLAN, allowing it to receive traffic from VLAN 2, route it, and send it to VLAN 3. However, the router still needs to know which traffic belongs to which VLAN. This is why VLAN tagging is used. When the switch sends traffic through the trunk link, it adds an VLAN tag to identify the VLAN. For example, traffic coming from VLAN 2 receives a VLAN 2 tag. The router reads this tag and forwards the frame to the correct subinterface. After routing the packet, the router sends it back through the trunk link with the appropriate VLAN tag for the destination VLAN. Thanks for watching, and I will see you in the next video.